Hey, Nathan here. Welcome back to another video for the PGL2D Alpha series. And in this video we are going to discuss the MoveableEntity class. So let's get started. We want to right click our game object folder and go to add and add a class. And we're going to call this MoveableEntity. And it's going to be a public abstract class, movable entity, and it's going to derive from physical entity, and it's going to implement iMovable. Okay. So the first thing, when an object can move, we want to set it up. In this framework, we want to set it up to restrict the movements. For example, if you have let's take a look at the classic platformers. You have a platform and you have a monster walking on that platform. You want to restrict that monster's movements so it does not walk past the edges of the platform. So once it moves to the left, and once it reaches to the left edge of the platform, it looks to the right and starts moving to the right, and it goes back and forth. So we need to restrict the movements of our object. And we're going to use bounds to handle that. So I'm going to create a private rectangle, and we'll need to add using Microsoft.xna.framework. And it's going to be a nullable type, so we'll add just a question mark there, underscore bounds. And that just, we're binding our object to a certain rectangle. So it cannot go outside of that rectangle. Alright, now let's implement the interface. So I'm going to use ReSharper and implement missing members. And I'm going to implement the values for the interface, which are float angle. It's going to be a public property. Float angle, public float speed, public vector2 velocity, and public vector2 acceleration. So you need to do that if you do not have ReSharper or anything that can add missing members in a few clicks that you saw me just do. So angle, I'm going to set up a private set, and I'm going to set speed to have protected set, and velocity is going to be private set, and max speed, acceleration is going to be protected set. Now we want to have another property for public float max speed, and that's just going to be get only. Okay. So now let's add methods, and then we'll need to add the constructor after that. So let's add a method that will update the velocity. Whenever our speed changes or our angle changes, we need to update our velocity. So we're going to set that up to be a private void update velocity. And that's going to be called whenever our speed changes or our angle changes. We'll just call update velocity. So velocity is equal to new vector2. Cast this as a float. Speed times math dot cosine the angle. And then we need to do the same thing for the y component. So cast that as a float. Speed times math dot sine the angle. So that just updates our velocity. So we don't have to constantly repeat that code that you see. We'll just call that method update velocity. Okay. So let's go and create the actual constructor now. So after our private field and before our properties, let's add our constructor. It's going to be a protected constructor, movable entity. We're going to provide the color vector to position, float angle, float max speed, string, actually I'm going to move that to a new line, string texture name, float rotation is equal to 0.0f, float scale is equal to 1.0f, rectangle bounds, and that's going to be defaulted to null. It's a nullable type, so rectangle question mark bounds is equal to null. Okay. Then we need to call the base constructor, so base open parentheses. We need to pass along the color that we provided, position, texture name, rotation, and scale. Okay, and then we open and close the curly braces. We set underscore bounds is equal to bounds, angle is equal to angle, speed is equal to 0. Speed is our initial speed. Our max speed is what we provide. So max speed is equal to the property max speed is equal to our parameter max speed. Acceleration is equal to vector2.0. Okay, and the last thing we want to do is call update rectangle. So that is a protected method in physical entity. So just call that. Okay, so that's it for the constructor. So now let's move on to the actual other methods as well. So we already have update velocity. Now, in some cases, if you have a, for example, let's say you have a power-up. And a power-up, let's say you're making a game and you have power-ups and you're fighting enemies. One of those power-ups might be to throw up an invisible barrier where your enemy cannot escape for, let's say, 5 seconds. And then that object's just stuck there. So we want to have this enemy is not going to be defaulted to be bound by any limitations. Or maybe it is, and you're just restricting that bounds even further. We want to have another method to bind the enemy, and then we want to have a method to unbind it when that power-up is finished, for example. So public void bind entity rectangle bounds. We're going to bind it by bounds. Underscore bounds is equal to bounds. Public void unbind entity. And that's going to just set underscore bounds is equal to null. Okay. This next method. When an object is... This is a movable entity, so it can move. When the object is static, it's not moving at all. The initial process, when it goes from not moving to moving, we want to have that in a special case. So we're going to call that start. Public void start. Nullable float initial speed is equal to null. That sets it up to be initial speed. If you want it to initially start at 7 instead of 0 and slowly accelerate. We're not using acceleration in the Alpha series. It's there, so it's easily extendable. You can just use it when you want to, but we're not using it right now in the Alpha version of the series. Okay, so going from not moving to moving, that process, we're going to call that start. So we're going to check to see if we have a speed already. We have already started moving, so we don't need to do this anymore. If speed is greater than 0, just return. Otherwise, if initial speed does not equal to null, so we have provided an initial speed, speed is equal to math.min initial speed.value or max speed. If the maximum speed the object can travel is 10 and we provide 100,000, we want to make sure that it only goes to the maximum speed that it is allowed. Else, if max speed is greater than 0, speed is equal to max speed. So we did not provide the initial speed, so we are moving by the maximum speed that object can move. Again, once speed or angle changes, we need to call update velocity. That's why we created that method, otherwise we'd have to do this multiple times, and code repetition is a very bad thing. Now, code repetition in the case of calling a method, that's, there's no way around that. But code repetition in this case, if we want to change the way that the velocity is updated, that's why code repetition is a horrible thing. Because all we have to do is just change it in this method, and that's being called elsewhere. If we did actual code repetition of this line here, and we come later on, and when we do the beta series, we might change the way that the velocity is updated. Okay, now we need to update it multiple times instead of just updating it once in this method. Okay, so that is start. Now let's do the opposite, where we're going from a moving state to a stopped state. In that process, we're going to call that stop. Public void stop. Stop, obviously, we're going to set the speed to 0. And we can call update velocity, or we can just set velocity is equal to vector 2.0. I'm going to call update velocity in this case here. Either way is fine. We know that's going to be 0, but if we need to do other things when we update our velocity, it's a good idea to just call that method. Okay. Now, angle here, that is a private set. We're going to change our direction by using the public accessible method. So public void change direction. We need to provide the new angle, float angle. So our angle changes, again, whenever our speed or our angle changes, we need to update our velocity. There are two more methods I want to implement, and this is the case where if we want our object to speed up or slow down. Again, we're not using the acceleration at this time, but there might be some additional cases where you have status effects, and that not only are you accelerating, your speed is increasing but due to the acceleration. When we eventually do use that, if we have some kind of power-up or status effect that we do want our object to speed up or slow down, we need to have that as well. Public void speed up float delta speed. If delta speed is less than or equal to 0, return. Speed up needs to be positive. Speed is equal to math.min speed plus delta speed and max speed. We still want to limit our maximum speed our object can travel. Our speed is updated, so we need to update our velocity. Now we need to do the opposite, slow down. Public void slow down float delta speed if delta speed is less than or equal to 0, return. We want to slow down by a positive amount because we'll just subtract it. Speed is equal to math.max 0, speed minus delta speed. If we're going a speed of 1 and we want to slow it down by a speed of 5, we cannot go a negative speed. If you want to have that capability, just delete this check. Or not delete that check, but delete this math.max check. So if you want that functionality, just delete math.max. If you want to have your object travel a negative speed, just get rid of this here. Our speed changed, so update velocity. Okay, the next thing we want to do is override the update entity method. So I'm going to use resharper, overriding members, and it's going to be the update entity. And that just overrides the update entity method. So this is a movable entity. When our entity updates and it's movable, we need to update our velocity and our position. Velocity is equal to velocity plus vector 2.multiply acceleration float game time dot elapsed game time dot total seconds. Position is equal to position plus vector 2.multiply velocity comma cast it as a float game time dot elapsed game time dot total seconds. These are the physics formulas for updating the position and the velocity. And that is position has no setter. So in our physical entity, we have our vector 2 for position. It's a property. Let's set that to protected set. Now that we have a condition where we want to set that, we need to update our access levels and set protected set. Update rectangle. Our position changed, so we need to update our rectangle. Okay. Now, our object, our movable entity object can be bound to a rectangle. We need to check those bounds so it does not go through that. It cannot just escape those bounds. So let's set a private void check bounds if we are not bound, which means underscore bounds is equal to null. We just simply return. We don't need to check our bounds. Var temp position is equal to position. Var collision point is equal to rectangle collision point dot none. We have not collided yet. If rectangle dot left is less than underscore bounds dot value dot x. That means we have passed through the left side of our bounds. Temp position dot x is equal to underscore bounds dot value dot x plus origin dot x. Remember, our position is influenced based on our origin. If our origin is the center of our object, we need to update our position appropriately. Because with 3, 3, that's going to be a different location if our origin is at the center of the sprite versus if it's on the top left. Collision point is equal to rectangle collision point dot left. We have passed through the left side of our bounds. So I'm going to do the same thing for the right side. Now, we cannot have a collision on both the left and the right side, so I'm going to do else if rectangle dot right is greater than underscore bounds dot value dot right. So if the rectangle is greater than the bounds, we are going to set the temp position dot x is equal to underscore bounds dot value dot right minus origin dot x. And then we'll set the collision point we'll set that to be at the right side. Now, we can't have both a left and a right collision at the same time, but we can have a left top, left bottom, right top, or right bottom. So what we're going to do here is check the top and bottom, but we're going to combine it if we have a left or right collision. If rectangle.top is less than underscore bounds dot value dot y. So the top of our rectangle is pushing outside of our bounds, so we need to adjust it. Temp position dot y is equal to underscore bounds dot value dot y plus origin dot y. Collision point is equal to collision point double equals none question mark. We're going to set it to the top. Else, we're going to set it to combine. So collision point dot combine. We're going to combine it with the top. So if we have a left or right collision, we are going to combine it with the top, which will give us left top or left bottom, or right top or right bottom. Now, we can't have a top and bottom collision, just like we couldn't have a left and right, so we're going to use else if here. Rectangle dot bottom is greater than underscore bounds dot value dot bottom. Temp position dot y is equal to underscore bounds dot value dot bottom minus origin dot y. We're going to do the exact same thing we did when we tested the top collision. Collision point is equal to collision point double equals none question mark. We're going to set that to rectangle collision point bottom colon collision point.combine. We're going to combine that with the bottom as well. Okay. So once we tested all of our collisions, this holds our adjustment position. So if our position is 3, 2, and our adjustment's going to be 2, 2, we need to get that difference, which will be -1, 0. We need to go from 3, 2 to the resulting one, which is 2, 2. So 3 to 2, that's -1, and 2 to 2, that's 0 change. So var change is equal to temp position minus position. If change is equal to vector 2.0. If we have not changed, just return. We don't need to do anything else. If we do, let's call hit bounds, which we haven't made yet, but we'll go ahead and do that. We pass in the change vector, collision point.get normal. It's going to be inside. We're bound by box, so it's going to be inside normal and the collision point. Alright, once we have called hit bounds, we're going to call position is equal to temp position. And whenever our position changes, we need to update our rectangle. In the update entity method, we need to call check bounds. So after this method, let's go ahead and create our hit bounds method, the one we were just calling here. So public virtual void, it's going to be a virtual void, hit bounds, vector 2 change, vector 2 normal, rectangle, collision point. It's going to be a empty virtual method, base implementation, do nothing, which will probably extend this in a future release, but for right now, it's just going to do nothing. And it's going to be an optional method, so we don't want to make it abstract. Alright, save this file, and that is it for this file. So hopefully this tutorial ends out to be well put together. I had to split this up into 4 parts. And hopefully everything will just come nicely together. If there's a few hard cuts, just be aware of that. In the update entity method, we need to call check bounds. So I hope to see you next time for the video that will discuss collision. Thanks for watching.